Okay, so today what we're going to be working on is solving rational equations. Those are equations that have fractions, okay? Today we're just going to deal with the fractions that have monomials in the denominator. Okay, so I would like you to try this. I want you to try doing these two problems without a calculator. So I'll give you a little hint. For the number one, you want to distribute the negative first and then combine like terms. Number two, when you add fractions, you have to have like denominators. Okay, so for number one, I'm going to distribute the negative. So I'm going to keep the first parentheses the same. So that's 2x squared minus 8x plus 3 minus 7x squared minus x plus 4. Now combine like terms. So we have 2x squared minus 7x squared is negative 5x squared. Negative 8x minus 1x is negative 9x. And positive 3 plus 4 is positive 7. Okay, so number two. Remember, when you add fractions, you have to have like denominators. So you need to figure out what's the LCD. The LCD would be what's the smallest number that 3 and 5 both go into. So that's 15. So remember, you want to make the denominators the same. So I'm going to make them both 15. So I'm going to multiply the left fraction by 5, because that'll make the 3 become a 15. Whatever you multiply the bottom by, multiply top by. And I'm going to multiply the 5 by 3 and the top by 3. All right, so I'm going to get 10 over 15 plus 24 over 15. Now when we add fractions, you add the numerators and you keep the denominator. Okay? All right, so what we're going to be doing is solving equations. This is just an expression. So we're going to actually be solving equations. See, there's an equal sign. All right, so the first thing you're going to do is find the LCD. First, work with any numbers that you have, like I did over here. I found the LCD at a 3 and a 5, so the LCD is 15. And then you work with the variables. For your variables, it's always going to be the one with the largest exponent, okay? So for your variables, if it's a monomial, largest exponent. All right, and then what you're going to do is you're going to multiply all the numerators, only the numerators by the LCD. Okay, and then you're going to reduce. The goal is to get all the denominators. I actually have numerators here, but denominators equal to 1. It says it on your paper, but I didn't get to change it on here. Okay, so that's the goal. The goal is always to get the denominators to be equal to 1. Then you're going to solve. You might have to use factoring to solve. Depends if you have a quadratic. And then you do have to check these. But we're just going to use the calculator to check. Okay? So let's take a look at number 1. All right. So the first thing I see when I see number 1, which says 3 over x equals 1 plus 2 over x, I notice that this 1 is not a fraction. So I'm going to make it a fraction. So I'm dealing with all fractions. So I'm going to put the 1 over 1. Okay? So now, what I want to do is figure out what's the LCD. So the LCD, look at the denominators. I have an x, a 1, and an x. So 1 is not going to do anything for me. But I have an x and another x. They both have the same exponent. They're both x to the first. So that means my LCD is x. So I'm going to multiply all the numerators just by x. X, x, x. Notice I put the x right above the number, right next to the numerator. Now what we're going to do is reduce. This x and this x reduce to 1 and 1. That's what I want, 1 and 1. So then I'm left with just 3 here, equals. Nothing here reduces because this is already 1. So this is just 1x. And then I have here x and x. They're going to reduce to 1 and 1. So I'm left with just plus 2. Okay, so now we're going to solve this. Minus 2 from both sides. X is equal to 1. Now you do have to check these, okay? So when you check these, you do have to check the original. Okay? So the original, which I wrote all over, was 3 over x equals 1 plus 2 over x. All right, so this is your check. So we're plugging in 1 here. So it's 3 over 1 equals 1 plus 2 over 1. You actually don't even need a calculator for this. So this is 3 equals 1 plus 2. Yes, 3 equals 3. Check. Okay, but you can use a calculator if you want. All right, let's try number 2. All right, so let's take a look at all the denominators. I have a 4r squared, 2r squared, and 4r squared. So you're going to work with the numbers first. You have a 4, a 2, and a 4. So part of the LCD is going to be, well, what's the smallest number that 2 and 4 go into, which is 4. All right, now we have an r squared, an r squared, and an r squared. They all have the same exponent, so it's going to be r squared. So my LCD is 4r squared. So we're going to multiply everything by 4r squared. All the numerators, only the numerators. Now we're going to reduce. 4r squared reduce, so I'm left with 1 equals. 2 reduces to 1, 4 reduces to 2. R squared reduces to 1 and 1. So then I'm left with 2, right? Because 2 times 1 is 2. Plus 4 and 4 reduce to 1 and 1. R squared and R squared reduce to 1 and 1. So I'm left with plus R minus 4. All right, now we're going to solve this. So first combine like terms. So we have 2 minus 4 is negative 2 plus R. Add 2. R is equal to 3. Sorry, that's my dog. She rings the bell when she wants to go out, so hold on. Okay, so now we have to check this. So here's our check. Remember, check original. 1 over 4r squared equals 1 over 2r squared plus r minus 4 over 4r squared. So we're plugging in 3. 1 over 4 times 3 squared equals 1 over 2 times 3 squared plus 3 minus 4 over 4 times 3 squared. All right, so you're going to use your calculator. Plug this side in first. Use the fraction key. And you get 1 over 36. And then plug this all in at one time using the fraction keys. And they are equal. 1 over 36 equals 1 over 36. So this works. All right, let's take a look at number 3. All right, so let's take a look at the denominators. I have an x, a 6, and a 6. Okay, so my LCD is going to be, start with the numbers. So I only have 6 and 6. I have no other number, so it's just going to be 6. And I have x. No other x's, so it's just 6x is the LCD. So we're going to multiply all the numerators by 6x. 6x, 6x, 6x. Now you're going to reduce. So x and x reduce. So I'm left with 6 times 1. So that's times. Don't add them. Is 6. 6 and 6 reduce. So be careful here because you have this x left on top. And it's x times x minus 6. Plus 6 and 6 reduce. So I'm left with x. 1 times x is x. So you're going to distribute the x here. So we get x squared minus 6x plus x, sorry. And 6 on the other side. Combine like terms. So we have 6 equals x squared minus 5x. So notice it is a quadratic. And how do I know it's a quadratic? Well, because it has an x squared. So I have to get it to equal 0. So I'm going to minus 6. 0 equals x squared minus 5x minus 6. All right, so it is a trinomial. We're going to use master product. So we multiply the first times the last. Negative 6x squared. What multiplies the 6 minuses to a 5? That would be 6 and 1. They're going to get different signs. When I add them, it has to give me negative 5, so it has to be negative 6 and positive 1. Bring down the ends. All right, now we factor by grouping. So group the first 2, group the last 2. The GCF of the first group is x, and then we're left with x minus 6. Notice there's a plus here, so I put a plus here. The GCF is 1, and then I have x minus 6. So my factors are x plus 1 and x minus 6. T-chart. Set each factor equal to 0. Minus 1, x equals negative 1. Add 6, x equals 6. And then you do check these. And I will tell you that both of these do work. Okay? This way it just saves a little bit of time. All right, so number 4. Let me just get rid of this top piece here. All right, so number 4, again, we're just going to start off by looking for the LCD. So let's take a look in the denominator. Look at the numbers first. So I have a 2. 2 is the only number in the denominator, so I'm going to use 2. I have an x and an x squared, x squared. So it's always the one with the biggest exponent, so it's x squared. So I'm going to multiply all the numerators by 2x squared. And now we're going to reduce. Okay, ready? 2 and 2 reduce. X and x squared reduce to 1 and an x, right? I have more x's on the top. So then I'm left here with 1x. Minus, because there's a minus here. X squared and x squared reduce. So I'm left with minus 6, because 2 times 3 is 6, equals. X squared and x squared reduce. So I'm left with 2 times, notice I'm using parentheses, x plus 4. All right, now we solve. X minus 6 equals 2x plus 8. All right, so I'm going to minus x. Negative 6 equals x plus 8. And minus 8, we get negative 14. And then you do have to check it, and I will tell you, because I already checked them at home, this does work. Okay, so that's it, and we'll practice in class tomorrow. Hopefully it wasn't too bad since we're only dealing with monomials right now. Okay, so everybody have a good night, and I'll see you guys tomorrow.